Alright guys, welcome to my cozy video corner. Today we'll be learning about bioart from Callie Chappell. Come check out these really cool projects that Callie is sharing and stay for the fascinating biology vibes and knowledge that you can do this at your home as well. Have you ever considered the ways that art and science can be combined? While they might feel like two completely different subjects, they actually have a lot more in common than you think. So let's hear more from Callie.
Hi, my name is Callie. I am a scientist, an artist, and a community activist that's passionate about making everyone believe that they are a biologist. So I am both a scientist and an artist, and as a scientist, I study how tiny organisms like bacteria and yeast and other fungi can have huge impacts on California ecosystems. And I also work as an artist as a scientist, translating scientific ideas, for example, in scientific papers, into things that are really visually interesting and things that communicate what's going on to a broader audience through drawing, scientific illustrations, and creating figures, and helping scientists communicate their research through art. I'm also an artist and arts educator where I do workshops with community members, so youth and elderly people who might see themselves as scientists like researchers at a field station, or people who might not yet see themselves as scientists but definitely are, like youth who work in the fields in the Salinas Valley, to reimagine both what science and art is through the lens of culture and creativity. So today we were doing two different bio-design art science projects, one with Kombucha Scobies as a bioplastic, and the other is growing sculptures out of a living material, Mycelium, which is the root of a fungus. Now, both of these ideas I didn't come up with. They were things that were shown to me by elders and also youth through a program called BioJam. I was introduced to BioJam Camp, which centers youth creativity and culture in biodesign and bioengineering, by my dear friends Rolando Perez and Corinne Okada Takara. The Kombucha bioplastics and Mycelium was part of the camp curriculum, but originated far beyond camp. When sharing teachings like this, it's incredibly important to acknowledge people when carrying on the teachings others generously share, especially those in community spaces. I especially want to thank Corinne, who taught me everything that I'm about to share in this video in her home, in her backyard, in our lab, on street corners, and so many other places. She is an incredible bioartist and educator who didn't just teach me about these materials, but influenced my entire approach to thinking about science and art, and especially how to center community in these conversations. And of course, not just me, but many others. I hope this video can carry on some of the amazing learnings and teachings that Corinne shared with me. The lineage of knowledge goes beyond Corinne, and I want to acknowledge many others as well. First were some really amazing youth and BioJam alumni, Emily Takara, Ann Hu, and Trisha Shatish. They made these Mycelium and Kombucha bioplastic kits called the Grow Your Own or GIY Bio Buddies as part of the Biodesign Challenge, and they won the youth division for it. I also want to thank the Tech Interactive Museum in San Jose, California, especially Anya Scholes, also Melissa Ortiz, an artist and educator based in Salinas, who carried a lot of the Mycelium work forward with BioJam, Rolando Perez, my dear friend and Mycelium expert, and NASA Senator Armstrong, who helped with this video and has always been my partner in growing Mycelium, and of course many others. So even though I'm presenting this today, what I'm sharing carries with it the knowledge and generous sharing of many others who came before me.
Now we are going to be making kombucha leather or SCOBY bioplastics. So I'm actually making kombucha, and when you make it, you use this big thing that looks like a big ring of snot that's called a SCOBY, which stands for a symbiotic culture of bacteria and yeast, SCOBY. And so the SCOBY has a bunch of microbes that carbonate, that produce CO2, that makes the kombucha fizzy, and also gives it a lot of other interesting tastes. So what this is a big container of what started out as tea. We've got some tea right here with lots of sugar in it for those microbes to eat. And we added some existing kombucha in a big SCOBY that I got donated from Foxtail Fermentation Product in San Jose, California, and that has now grown into some kombucha. So what we'll be doing is actually pouring out some of the kombucha into this growler here to drink later, and to put in some new food for those microbes with this fresh sweet tea. So inside of this container, it's a microbial soup. So just like the mothership is the big SCOBY, there's actually bacteria and yeast swimming around in this entire big container. And so what we want is we want those microbes to go in these petri dishes with the new food I just put in, so they can grow a new SCOBY in every single little petri dish. So what I'm doing is I'm literally just pouring out a little bit of that kombucha into each of these petri dishes. So that kombucha, because it's coming from the big one, contains that symbiotic culture of bacteria and yeast.
All right, it's been a couple weeks, and you might remember these plates that we poured this kombucha out into, and they have grown tiny little SCOBYs inside of the petri dishes that we can dry to form a kombucha bioplastic. So how are we going to dye these guys with a cool, fun color? Well, these I dyed using just regular food coloring, but I thought I'd try something cool today and see if we could use a natural dye. I was really inspired by blues, and so I thought, what creates a natural blue color? Some pea flowers.
So now we have our beautiful blue pea flower tea, and something that the bacteria and yeast really like to eat inside of the SCOBYs is sugar. Turns out that the microbes also like to drink sweet tea, not just humans. So inside the plate, there is a tiny SCOBY, and what I'm gonna do is just pour in this blue tea into there, and you'll see it's gonna turn light blue. So these are some SCOBYs that we started growing a couple weeks ago and that I already dyed several days ago. And you can see that there's this really thick SCOBY in there. And now we need to dry it out. So because it was sweet tea, it has a lot of sugar, these guys are really sticky. So what I want to do is I'm actually going to take it out of its petri dish. Whoa, look at that. It's going to slide out of there. It's like a hockey puck of snot. And I'm actually going to wash it off inside of this bowl, just to kind of get some of the excess sugars out of there. They'll stick to a lot of different stuff, and then it's really hard to peel them off, but they actually don't stick very well to wood. So what I'm gonna do is I'm gonna harvest all of these by putting them on this wood block, then I'll put them out in the sun, and then they'll dry into almost tissue paper like material that's really beautiful, and is depending a little bit on the dye. So that one was kind of a turquoise. This one's more of a deeper blue purple. So let's harvest this one. Whoa, look at that. Okay, let me wash it off. So I'm gonna harvest the rest of the SCOBYs. I actually grew like about 100 of them, and we'll see what they look like with the tissue paper when they're done. Wow, look at that. It's so beautiful. Did you know that you can grow stuff out of mushrooms? Well, not exactly mushrooms, but actually the root that is under every single mushroom, known as mycelium. So if we look at this woodblock print of a mushroom, under every mushroom is this vast web of a network of mycelium that lives below ground. So today what I have is actually some sort of waste. So if you like chocolate, every time you make a bar of chocolate, they come in beans, in these cocoa beans, and outside of each bean is a husk. And so when chocolatiers make chocolate, they don't need those husks, and sometimes they can go to waste. The cocoa bean husk that we'll be using is from Dandelion Chocolate, a really amazing chocolatier in San Francisco, California. And so what I have sterilized cocoa bean husks with some water, so they've got a little bit of liquid. And then what I did was I actually took mycelium that came from a company that I was able to order online. This is reishi mycelium. So if you're familiar with reishi, sometimes it's used in some medicines. It can be a really good substrate. It can be really good at growing structures. And I put it into those cocoa bean husks and I let it grow for a week. So you can see there's all of this white fuzzy stuff, and that is the mycelium. I also was growing a little bit of oyster mycelium. So if you've ever had oyster mushrooms from the grocery store, this is what grows underground. So I'll be using reishi and oyster mushroom mycelium to grow some sculptures. And the sculptures that I thought would be really fun would actually be food. So what these are plastic shapes of some different foods. This one happens to be a dumpling that I will be putting this mycelium into and growing them into these fun shapes. So let's do it. I just put my gloves on, and the first step is to sterilize the environment that you're in. So what I have here is 70% ethanol. So ethanol is an alcohol, so this can be used to actually kill microbes. These mycelium are microbes, and so we use microbes all around us. There's bacteria and yeast and other fungi. Well, we don't want those fungi or those yeast or those bacteria to grow when we're just trying to grow one type of mycelium. And I'm gonna choose one shape. So I'm gonna do the dumpling first because I love dumplings. I'm gonna take the reishi mycelium and I'm gonna press it inside of this mold form, and then I'm gonna put it inside of a plastic bag. So while this is drying off, I'm gonna label my plastic bag. So I'm gonna open up the jar. Ooh, and you can see the mycelium's growing so good. All that fuzzy stuff is mycelium. And I'm just gonna pick it up. Look at that. Oh my gosh, it's so cool. And I'm gonna press it into the mold form. So you can see it's so fuzzy. It's actually been growing out from the cocoa bean husks that are in there. And so I'm gonna try to press it really good into as much of the mold form as I can. But if it doesn't get into every single tiny nook and cranny, the mycelium will actually grow out to fill it up. Now, because these are living, breathing organisms, we have to leave an air hole to make sure they can still breathe. So I'm not closing it all the way. I'm leaving a little bit of an air hole in the corner. And now this is ready to go into a nice, warm, and humid place. I like to grow these in my bathroom. Check back in on them in about a week and see how they grew. So it's been about 2 weeks, and so they've grown pretty good. So here we go. This is a Mycelium empanada. I actually took it out of its mold like maybe a week ago, so this was the mold shape. Here's the fungus about a week ago, so we can get this nice fluffy mycelium growing all the way over because it needs air just like we do to breathe. And now it's ready to go. So this is still growing, so we want to deactivate it. So we're going to deactivate it in an oven. I've got the oven set for between 120 and 180 degrees Fahrenheit. We'll bake this for about an hour. It depends a little bit on how big they are. This one's quite large, so it might take a little bit more than an hour. And then we'll have a nice deactivated mycelium empanada. So we've taken these out of the oven, and as you can see, they've gotten a lot harder. They even got a little bit toasted, and they have been deactivated. So these are ready for you to give to your friends, your family, anyone who might want a mycelium empanada. But truly, this is kind of a fun example, but you can make so many things out of mycelium. Imagine if the walls of your house were, instead of made out of concrete or stone, were actually grown out of mycelium. What if your favorite handbag was made out of mycelium? What if the coat that you were wearing was made out of mycelium? This is such an interesting biomaterial that we literally fed compost to and are able to grow into so many different things, even an empanada.
So Callie, what inspired you to do both art and science?
So I grew up in rural northern Michigan. I'm adopted, and I grew up running along the shores of Lake Michigan and picking wild apples and wild berries and being an artist. I've got a bunch of family members who are artists, and I grew up with a close family friend and art teacher who taught me to understand the world through looking at it as an artist. So looking at the iridescence of a dragonfly's wing or dew on a fiddlehead fern and sketching that and really looking closely. And so I never imagined that I would become a scientist. It wasn't until I started studying biology and ecology in particular as an undergrad that I learned that so much of those observational skills as an artist were also central to being a scientist. So today, as someone with a PhD in biology and as well as being a professional artist and arts educator, I really see those two practices as being one and the same, that being curious and being creative is central to answering questions, asking questions about the world, and creating products, whether those be paintings or whether those be bioart or whether those be scientific papers and data that represent how we see the world and how we understand it to be.
What is your advice to people who want to do more art and science together?
If you want to get started in sci art, just do it. I didn't really see the relationship between my science and, drawing or sketching at home until I was on Twitter one day and I saw this guy, Alex Kagan, who was drawing sketches from conferences, and I was like, and sharing them online. I was like, that's really cool. I could totally do that. So I started doing that. People were like, hey, I saw your sketches on Twitter. Could you illustrate a figure for my paper? And I was like, yeah, I could do that if you pay me. And then once I started doing that, I was like, I'm actually a professional artist because I'm getting paid for my art. Can I share this back with scientists? So teaching them the graphic design and illustration skills that it takes. And so I started doing that. And then I was like, hey, what about audiences that are not scientists who might actually see art as an entry point for thinking differently about science? So I started doing these workshops with artists for youth and community members. And through working with these artists, I learned all about this world of artist residencies and gallery shows. Through their generous teaching, they taught me how to do this bioart that I was sharing with you during this video. I'm using biological materials to make art. So it all started with me just being inspired, and I say go for it.
Guys, learning about the SCOBY bioplastics and what you can do with mycelium, that was super cool. If you want to try this on your own, there will be process videos on the channel. What other ways have you been able to combine art and science? I would love to know and be even more inspired. See you in the next video.